In this video, we're looking at linear functions. Some of you may already know what a linear function is. It's just a straight line. So a linear function has two forms that we use for its equation. The first one is what we call the intercept gradient formula. So that's our y equals mx plus c. And then we have the general form, which is ax plus by plus c equals 0. And you can see those at the top of your screen. Now, its graph, when you go to graph these, is a straight line with one x-intercept and one y-intercept. So what that means is it crosses the x-axis at one point and it crosses the y-axis at one point. Now, if we had to write an equation for the amount of milk in n lots of 3 litre bottles, we're going to use our intercept form first. So our y equals mx plus c. But essentially, our milk will be our y. That's our total. And then our n lots of 3 litre bottles, well, it's 3 litres per bottle, so 3n. Alright, so if we have 2 bottles, it'd be 3 times 2. If we had 3 bottles, it'd be 3 times 3. So n is our variable. It's the amount of bottles we have. So that's how you create an equation. Really quick and simple. Now, with linear functions, it's important to note that the domain, which remember is all the possible x values, goes from negative infinity to infinity. All the way in the negative direction, all the way in the positive direction on the x-axis. Now, the range is the same from negative infinity to infinity. It goes all the way down, it goes all the way up. All right. So if I had something such as here, let me just do it up quickly. Here's my linear graph here. What this is saying is it's going to continue going this way for infinity. It's going to continue going this way towards negative infinity. And then in the same this way, it's going to go all the way up to infinity. And then in this direction, it's going to go all the way down. So if I had to write that, you'd write it what is up there in those curved brackets. Now, a type of linear function is called direct variation. And so a direct variation occurs when one variable is a constant multiple of the other. So as one increases, so too does the other. Usually they take the form of y equals kx, where k we call the proportionality constant, but it is very similar to the gradient. It's how steep or how quickly it's going up or down. In this case, you can see an example here. They do not go past 0. So if you'd see down here, this little part down here, that's not there. It goes to that little point there, and that's it. All right. So it doesn't go towards the negatives there. It always crosses the origin at 0, 0. So that's also an important note for direct variations. The next thing we're going to look at is actually graphing linear functions. So most of you already know one of the ways to graph these type of functions. It's the table of values. It's very common. Here we could have a table like this where you have your x values that you pick, -2, -1, 0, 1, 2. And then let's say we had an equation such as, I'll do it in blue, y equals 2x plus 1. Let's say we had that. What we would have to do here is we substitute in our x values on the top. So for the first one, y equals 2 times -2 plus 1. And that gets me -4 plus 1. So -3. And then that would go in there. And you continue to do that until you fill up your bottom y values. Once you've done that, you can then plot those points on your grid and create a line joining them. The other way that I'm going to teach you that I think is a lot quicker is where you find the x and y intercept and you plot it using that. So let's say I had something such as y equals 3x plus 9. We want to find our x-intercept, and that occurs when y equals 0. So here we have 0 equals 3x plus 9 minus 9 minus 9. Then we want to divide by 3. So we get x equals -3. Over on the right, let's write the y-intercept. Let x equals 0. So we get y equals 3 times 0 plus 9. So y equals 9. Alright, at this point, we can actually plot these on here. So if I had down here 1, 2, 3, 4, 1, 2, 3, 4, and these are all negative. And then 1, 2, 3, 4, 5, 6, 7. I didn't go high enough. 8, 9. You put dots where it's crossing. So for my x, it was at -3. So I'm going to put a little red dot down here. And for y, I was up here at 9. Get out your ruler. Draw a line that connects both the dots as best you can. I'm just going to do there for now. And there you go. That would be my graph of that line. So x-intercept, y-intercept, find your 2 points, plot it on there, draw a line. It is definitely quicker than creating a table of values and then having to substitute in each value, find it, write it down, do another, write it down. X and y intercepts are a lot quicker if you have good algebra skills.